I guess we can begin. Is that fine? Hello.
Yeah, we can start,
Am I
Ayush.
audible?
Yeah, you are.
Uh,
We can
all right,
start, Ayush. Yeah.
we'll start with the
Sure.
introduction then. Hello everyone. My name is Ayush Sharma. I'm a convener for the Analytics Club. I'll be hosting this session along with my co-convener Srishti Yadav. AI has had a long journey, and what started as a simple chatbot has now ingrained itself into almost all aspects of our lives in the form of AI agents. To truly understand how AI agents have consolidated their position as digital colleagues, we have organized a Meet the Expert session so that all of you may, well, meet the expert.
Allow me to introduce our speaker for this session, Mr. Chakrapani Mishra. He's an ITB alumnus from the class of 2000, which adds up to an insane 25 years of professional experience. Throughout his career, he has led and managed multiple engineering teams and founded AI based startups. He currently works as a principal machine learning scientist at Adobe, building AI systems that empower millions of creators worldwide. In case you have any questions, we encourage you to type them out in the meeting chat. Sir, you may take over the session now.
Okay. Thanks a lot, Ayush and Srishti. Really happy to be back to interacting with IT Bombay folks. Always a pleasure. It was some of the most wonderful years for almost every one of us in the batch, and I think you all folks also must be enjoying your stay in IT Bombay. So really happy to take this session, and thanks to Ayush and Srishti for coordinating and managing the backend with me. Okay, so sorry, got a phone call. Okay, so we can start. So, but before, can you just give me a second? Yeah, sorry. Uh, okay, so before we start, I just want to probably get a feel of how many of you have used some kind of LLM like ChatGPT or Gemini in last, let's say, 1 month. So you can just react with a thumbs up for any purpose. So just want to get a feel of how many of you are using LLMs, Gemini, ChatGPT, Claude in your daily life. Okay, great. And now my second question is, how many of you have really built something using these LLMs, Gemini, ChatGPT, Claude, whatever? Have you guys built something over last, let's say, 1 quarter, last 1 year using these tools? Okay, great. And how many of you have really uh, used these systems as agentic AI? Has any one of you created something using agentic AI frameworks? Or it was primarily putting a prompt in some kind of a LLM like Gemini and all, and getting a response and again prompting it back to get another thing done. So I guess very few of you have really worked with agentic AI per se, but it's not something which is like a rocket science kind of a thing. It's very simple extension of what you folks are already doing. So I will just share my presentation and we can then start. Okay, so I hope it is visible.
Yeah, it's visible.
Okay, fine. Okay, as Ayush already mentioned, I'm working as machine learning principal scientist in Adobe. And to be frank, back in 2000, I had absolutely no inkling that I would be working in AI for last 10 years or so. I have been in this particular domain. So there was nothing like LLMs or chat GPT. Even cloud computing was not there. Smartphones were not there. Even Google was at a very nascent stage, just 2 years old when I basically did my BTech. So what I'm trying to emphasize is that technology shifts very quickly. So what you folks might be thinking today is very important might not be the case, let's say 10 years, 15 years down the line. So you need to be able to comprehend, understand all these technological shifts, and accordingly adjust your career path or whatever interests you. Okay. So in this particular session, I will first talk about agentic AI. I'm not going to go very deep in any of these aspects. It will be an overview of agentic AI, what it is, how it works, what kind of mindset shifts are required to work in agentic world. Uh, and then we will talk about two philosophical questions, which are very prevalent if you are in AI world. So, is software engineering really dead? One is this: you keep hearing about uh, software engineering as a career option getting overtaken by AI. So, how much truth is there in that? And what is the best survival strategy in this AI world? And finally, we will also talk about one simple, not exactly simple, but a use case that we have implemented in Adobe. Unfortunately, I cannot go in too much detail of it, but you will understand the basic concepts behind what we are trying to do because of IP related issues. So let's start with what exactly is agentic AI? Okay. So, as mentioned on this particular slide, there is a difference between a chatbot and what an agent can do. So, agent is meant to do your job. If there is a work to be done, we go to AI agents. Chatbots are more like interactive frameworks where you put a prompt, you get a response, and you again put a prompt to refine that. But AI agents are a little different. They can basically plan out the things for you. They can decide what is good, what is bad. They can basically act on their plans, and they learn from whatever has been achieved through the AI agentic framework and put that into their feedback loops. So that's a important distinction. So let's say, just not a very good analogy, but yeah, I mean, there is a IT Delhi fresher in my team who keeps pestering me with all kind of questions all the time before the job is done. Then there is IT Bombay graduate to whom I give a job. He goes outside, he just disappears, and he comes back with the job being completed. So that's the basic difference between a normal LLM, which is like ChatGPT or Gemini, and an agentic framework where you give a task and it completes the task to the best of its capabilities. Okay, so it tries to perceive, decide, act, and learn. So that's the basic difference. So to give you an example, let's say you are doing some research and you got some paper which in the past was related to that particular domain. You go to a chat gpt kind of an interface, you ask it to summarize it, it will summarize it for you. And then let's say you want five critiques or five key takeaways from that particular document, you again give a prompt to it and it will do the job for you. But let's say you're working on a BTech project, BDP, in your final year, and there are some important steps that you have to take before you really start working on the BTech project. So you need to basically understand the landscape that is there, basically the literature review. You need to search. You need to spend at least a week or so in searching that particular domain, what all people have done in that particular domain. Then you need to understand what all people have done. Then you need to create, let's say, a presentation for literature review and email it to your professor, who is your guide, basically. Now, the second task is more of a agentic AI kind of a task, uh, where a agentic AI framework can do all of these steps for you. It can search the internet, fetch all the relevant documents. It can summarize those documents in a very well formatted way. It can create presentation and also send an email to your professor. So that's agentic AI. Okay. And the question arises why that is happening now. Okay. So one very important thing is that LLMs have got very smart, and they have got smart both in terms of what all they can accomplish, as well as the context window that they basically can take as inputs. So just 2 years back, the maximum amount of tokens, so tokens, you can say that in machine learning parlance, tokens are like one word, one token is kind of 0.75 words. So that is kind of a rough conversion. So you can only give around 16,000 tokens to any LLM prompt. Now that has changed significantly over last 2 years. Now you can give a prompt which is a million words or million tokens long. So that changes a lot of things. People, because of this very capability that now LLMs can remember much more compared to 2 years back, you can expose a lot of other things like tools and APIs. You can expose your products, like for example, you have a calendar or you have a travel platform. You can expose your products through APIs or through MCP servers, so that these models can utilize that and do the job which you are doing right now. For example, creating a presentation or booking a ticket for you. Okay. Compute has increased a lot and has become cheaper. So that's another reason why agentic AI is being utilized everywhere. And there are real business needs. People want job to be done. They don't want answers all the time. They really want that I have given this task, it should get completed. So if there is a job to be done, the agentic AI framework should be able to at least complete 90 to 95% of that before human in the loop comes into the picture. So these are some of the factors why agentic AI is in now. So let's think about this technology stack a bit. Okay. So basically, what all is there in this technology stack? Okay, you can have a look at this slide. So they are, of course, foundation models which are kind of brain on which this agentic AI framework is built. So these are nothing but uh, very big LLMs to start with. The size of LLMs has increased a lot, as you all might be aware. So, for example, the latest models are like more than a trillion parameters. So they are huge. I mean, more than a trillion parameters means you have matrices which are storing more than a trillion floating point numbers to do these operations. Uh, they know little bit of history as well, because context window has increased. So you can play with lot of things because you now can send lot of context into a LLM prompt. People have started exploring and exposing tools to these LLMs, so that they can take actions using those tools for the jobs that you want them to accomplish. They can also do planning and reasoning because these models have become far more capable. And finally, they basically look at the goals that have been provided by a human. So as human, we need to provide clear and crisp goals, define what our agentic AI system should do, what is its capabilities, what are the guardrails under which you want to work with the agentic AI framework, and then it will do the job on its own with a feedback mechanism. Okay. So any questions till now? So Ayush, you can let me know if there is anything in the chat window. I will just have a look.
Yeah, sure, I'll do that.
Yeah. Okay. And I hope things are clear. If there is anything I can answer, I will be happy to answer that. Okay, so now let's see some real world agent examples. So I have just listed four different agentic workflows that people really have built into real world. Uh, but I want to basically go through these examples, but I want to understand, I want you to understand that underlying these different workflows, the agentic AI architecture is very, very same. So that is the key point that you need to understand. So using same kind of architectural backbone, you can create many different applications. So, for example, in a setup like, for example, Adobe, there's definitely a coding agent that almost every company is now utilizing. So, there are bugs that keep coming all the time in your products, and they come in hundreds of numbers. Uh, you need an agent or AI system which can understand these bugs. It should be able to understand from where that particular bug is originating, because the code size is humongous in large enterprises. It should be able to write the corrected code. It should be able to run unit tests, automation tests, and finally it should be able to fix the bug that is being reported from the field. And once all this is done, it should automatically raise a pull request on GitHub. Okay, so this is one of the workflows where, given a bug, you want to finally uh, fix your code base and raise a pull request, which can finally be merged with the main branch of your code base. There is a research agent, like we talked, which can search latest papers on a particular topic. It should be able to comprehend all those papers, give you a summary. It should be able to analyze it, compare different papers, what is there within each of those papers. It should be able to cite sources as well. Okay, so instead of searching and spending time, which goes into weeks, just to get the list of research papers which are talking about the area of research you are interested in, it's important to use these agentic frameworks so that you get more time for thinking part of it, building part of it. Okay. Similarly, this data analyst agent. Okay. So, what exactly this data analyst agent needs to do is, in any big enterprise, there is tons of data that basically gets logged every single day. So, for example, if I talk about Adobe Acrobat in per se, it has a monthly active user base of close to 800 million users. So 800 million users every month come on Reader and Acrobat and use that particular application. And a lot of clickstream data. So where exactly a user has clicked, what all tools it is utilizing, what is the scroll history, what kind of tools, editing operations the person is doing. All that gets logged in, but that data is humongous. There are millions of rows of data that gets generated every single day. So if we really want to get any insight out of it, we need to very clearly understand this data, which requires fetching the data using some SQL query. It requires cleaning and transforming the data, analyzing the patterns, and then creating visual charts out of it, which explain the insights. So, again, this requires multiple different logical steps, each of which needs to be performed autonomously. So, once we want these steps to be performed autonomously, given a goal, it is basically an agentic AI framework. Similarly, with the travel planner agent, so we all have experienced that if we want to book uh, any journey, we always open tons of tabs and we look for the best options, best flights, best hotels, where to go, and whatnot. This all can be basically done by an agentic AI framework where an agent basically searches the flights, another agent basically searches the hotels, some third agent does the optimization part of it. A fourth agent books everything once things are finalized. And it can also track and replan in case your plans basically get shifted. Okay. So, as we discussed earlier, how agents work is because it is not just the brain that is there, but we are also giving it hands and legs so that it can utilize different tools. It can keep things in memory, and it can plan the entire workflow out. And then, utilizing those tools and plan, it can produce something which is defined in the goal. And finally, it should be able to observe what the outcome is. It should be able to adapt that output and basically provide a feedback loop to the entire system so that your system keeps on improving every single day. Okay. So the thing that we need to understand is like in the last slide, I said every agentic AI framework has things in common, which is it has a goal, it uses tools, it uses context, it basically acts you based on the context that is being provided and the tools it has access to, and finally it delivers the outcome that you want it to deliver. Okay. So important distinction is that it is able to take actions because you have exposed tools on which your agentic framework can act on. So this is basically the anatomy of a real agentic AI engine. So of course, as I said, there will be a reasoning engine which is going to, given a goal, it will think, it will plan out all the steps that it needs to do. Then it will basically invoke different agents. Uh, it will preserve the context of what all has been provided to it using memory, or you can say because the context is large, it will utilize that context as memory. There will be tools that are exposed to it. So for example, search tools or calculators, or let's say weather application, or let's say if you are booking hotels, then the hotel chain might have provided an API endpoint. So all these are known as tools. Uh, of course, it will have a communication framework so that it can coordinate with humans in the loop. It will observe and it will finally do some action on utilizing all this information. There will be agent which will do a final action and provide the outcome. It will also have some feedback loops so that it can improve upon what it has delivered based on all the feedback that it is giving. So, as I mentioned again and again, tools are what make agents very useful. It's like, uh, let's say, Messi with the legs, you can say, right? So, Messi is very intelligent in terms of he understands the dynamics of football, he understands the field setup very well. But what he also has extremely good legs, which he utilizes while playing football. So, it is almost like that. So, it's like you have aircraft engine and then you have aircraft engine is very powerful thing for an aircraft. So LLMs are basically an analogy for aircraft engines, but to build an aircraft you need these tools. Okay, so it will have search or code execution tools or databases to which it is exposed, and it can basically access. It will have email or messaging services, or let's say it has access to analytics and charting tools. So utilizing all these tools along with your LLM prompt makes these systems very powerful. Okay. Okay, so I mean, here are some of the things which definitely are upcoming, and people interested in AI ML domain need to basically look into these aspects more deeply. So, agent architect is very critical aspects in large enterprises. How exactly you are going to build different agents which are going to interact with each other You need to basically also take care of in what state the output of one agent is, so that you are aware. You need to have an orchestrator in the system, which basically keeps track of what agent is activated, where exactly your output is, and all those aspects. So agent architect is a critical need for any agentic workflow or agentic software development cycle. So of course, API integration specialists are definitely needed. Then you need product managers who understand this terminology of agentic workflows. Key aspect, a very key aspect, is AI safety and governance. A lot of focus big enterprises are putting on this particular aspect, because these tools are pretty harmful as well in some way. Human agent collaboration designers. So even the design teams are now orienting towards how humans, uh, that is consumers, prefer to interact with AI agents, or let's say AI tools. So you need a collaborative effort from designers as well. And then, of course, there are agent operations engineer, which basically monitors and scale these agents in real world. Okay, so from purely coding, things are now shifting towards architecting, is how you should think about it. So, I mean, most of you all are IITians, so most of these things you already have ingrained. You focus on fundamentals. You all are very curious. You work in teams. So, I don't want to spend too much time on it, but there are few aspects like this point number 7: build ethical habits. So, there is a lot of things that are going on in AI world which are not fair. They are risky for privacy and safety. So whenever you are building any agentic framework or any product which utilizes AI, be very aware of these ethical things. So I'm not sure how many of you, if you have undergone this any AI ML course, you must have studied about harm and bias aspect of AI output. So I mean, some very simple things like, not now, but I mean, just couple of years back, when people trained these systems, because most of this training was done using the data that is available over the internet. So it has its own biases. Like for example, nurses are primarily females, doctors are primarily males. So these kind of things, these biases were there. People are trying to address these biases. There were also biases in terms of uh, racial background or sex or the language someone is speaking, and these kind of aspects. So you need to be very careful in terms of creating systems which are fair. It's very important. You need to keep yourself updated on a very fast pace. This space is evolving at a very rapid pace, and even enterprises are finding it very difficult to keep pace with the rapid evolution of this particular space. Um, and of course, if you are creating your own startup in this particular domain, you need to be a little patient. It always takes time for things to materialize and to understand product market fit and many other aspects. Okay, so mindset shift. This is very important, and uh, I came from a startup background working on AI systems into Adobe 4 years back. And I can clearly see the old mindset that is even now is prevalent, and people are changing, but it takes time to shift from old mindset to new mindset. So earlier, a very good coder was identified by how many lines of code it has generated. Now, that's not the criteria. It has shifted to what impact your code is created, because everyone knows that people are using AI coding agents in the background. No one is doing all the coding on his own. So those kind of mind shift changes are required. So from, let's say, I do everything, I will handle everything from everything myself. You have to think about agents and orchestrate those agents. You need to basically create an agentic framework and let agents handle most of the task, and you do the orchestration part of it. So second point is again very critical in big enterprises, emails, tasks, meetings, all this take up a lot of time. So rather than why not utilize an AI agent for summarizing some of these things and focus more on impact creation? Earlier, it was more of I know and I use these many different tools. Now it is more about how to expose these tools and build systems. Finally, very important, I fear being replaced. So it is a very common thing that you keep hearing in newspapers and media and social media all the time, that AI is going to take up this job and that job. I think, in my opinion, that's not going to happen so soon. Only thing is it will evolve. Like it did in any past innovation. So my belief is that the economic pie, whenever a breakthrough innovation happens, increases. It has happened when railroads came. It has happened when electricity came. It has happened when, let's say, mobile came and basically spread all across the world. So every past innovation, which was kind of a breakthrough and disruptive to the old way of life, in the end has created a larger economic pie. So AI will be different is still not clear, but I don't feel so. I still feel AI is going to create larger economic pie. It will create more jobs. It will give us more economic prosperity. Only thing is we need to shift our working style and start adopting these new way of working. Okay. So, I mean, here's the bottom line key takeaways. So, agents, as I mentioned, they decide, perceive, act, and learn. Agents utilize tools to be very powerful. Uh, Designing the agentic architecture is very, very critical. Um and they are creating new possibilities, as you all know. So I think the future is definitely bright, and this space is evolving at a very rapid pace. There are things to be built. There are a lot of startup ideas that you folks should bring to the table using this framework, whether it is on the application layer or the model development side or the algorithmic side. But that is something which is required quite a lot. Okay. So here is this philosophical question. So is software dead? So actually, we internally have a group, IT Bombay batch of class of 2000. So just last year, we had our 25th reunion. So we connected back with everyone and really enjoyable times. But it also led to creation of some of the groups. So we keep discussing these topics on those groups and really interesting things. So Gautam is again a batchmate from 2000 electrical engineering department. So he's currently with Uber in US. So basically, this slide is from him, and I really basically uh, correlate with this quite a lot. So that's why I thought of bringing this way of thinking for you guys as well. So as mentioned here, I think software is going to get even more important. Only thing is, uh, the abstraction layer is moving, so that all of you need to actually focus and understand very clearly. If you are still writing every single line of code, that's probably not the way to go. Okay, so it is a misconception that AI can write all code and software engineers will become redundant. There are still a lot of bottlenecks, but only thing is they have moved up the value chain. That you need to understand very clearly. So you need to understand the architecture, you need to understand the requirements and intents. One very, very big problem in large enterprises today is how to evaluate AI generated output. So much slop is getting created due to AI that evaluating the AI outputs has become a very big challenge. Uh, Reviewing the output or even the code that AI is generating is a big bottleneck in enterprises. Explainability of AI systems is again something which is a focus area. So you need to understand. So when just around 15 years back, every enterprise used to have their big server teams. They used to have servers inside their premises, and there used to be a team which used to manage servers, and it used to be a lot of pain for them as well as employees, because you need to manage those servers, you need to maintain those servers, you need to allocate those servers to different employees, and all this takes a lot of bandwidth. Then came the cloud technology, like AWS came, and everyone thought that these backend server engineers' job is at risk. But actually, that's not how it evolved. So AWS, though it made life very easy, it basically opened up a lot of new things like distributed system, Kubernetes, networking, reliability at scale, and all these aspects. So engineers became even more valuable. So same is going to happen in this AI era as well. So don't focus on code writing all the time. I understand understanding the fundamentals of programming is critical, understanding data structures is critical, but writing every single line of code in today's world is not at all important. So these tools like Claude, CLI Claude Code or Cursor, they are very good in writing codes. Utilize those tools along with uh, the design thinking that you can bring to the table. So that's very important. Volume and value today are not correlated at all. Okay. So you need to focus on what matters, designing the right agents, architecting them, and that's how you have to plan your career around AI paths, and not just in software industry, even in other places, even in consulting and other domains. So this is one strategy which I really like again from one of my batchmates from 2000. So it's basically the barbell strategy. So what it says is that you need to be at both the ends of this barbell. You need to be close to AI as well as you have to be very far away from AI. So this particular slides very neatly captures this particular idea. So you need to study AI, of course. You need to think in AI terminologies. You need to build with it. So you need to basically be very deep in understanding what AI is, what agentic AI frameworks are, what they can do, what they cannot do, and all that. Okay. Uh, but you also need to, if you really are going into enterprise settings or even research settings, you need to understand the value of humans and why humans are different. So trust, taste, courage, stories, love, and leadership, empathy, and all those qualities are still very important in enterprise settings. So you need to focus on developing those particular aspects of human behavior along with understanding AI at a very deep level. Okay. So a, a critical aspect of this particular strategy is that you need to avoid the middle thing now. So that is very, very critical. So spreadsheets, for example, you can create just few years back, even creating a pivot table on Excel sheets used to be a valuable skill. It's no more a valuable skill. Okay. So anything where AI is better at comprehending and doing your task, utilize that. Okay. So repeatable cognitive task, humans cannot match AI at all. Okay. But that doesn't mean that we need to be distinct from AI. We need to collaborate. We need to basically work in a collaborative framework with AI as a supporting structure around us. So humans still give that particular edge. So in a team, connections, judgment, originality, these are very important, and these will remain important even in future. Okay. So just don't be in the middle. So you need to develop your skill set at the two ends of this particular framework. Okay. So just one more thing I want to bring back. Okay. So before we move on, I just want to bring in few aspects. What basically agents are still not able to do. So that is very critical to understand. Uh, so there are a couple of things. So you need to whoever has taken any AI ML course understands that in the end any LLM is just next word prediction model. Okay, they can be a trillion parameter model. What in the end they do is you have a vocabulary which could be 50,000 words or it could be 1 million words. They just pick one single word based on some probabilistic model and spit it out. So it is there. These are still next token prediction models. So they are still not continual learning frameworks. So that's where, as humans, we can learn new things in any new environment. So just to give you an analogy, so when I went to IIT Bombay in 1996, and I think many of you can relate to it, it was my first time to Mumbai, and it used to rain a lot, right? So it was a very new thing to me that it's raining for days together. Okay, but as human beings, we adapt to that particular environment very quickly. We continually, we are able to learn continually, which LLMs are not able to do. So they are basically frozen in time. So once your training is over, they are frozen. Okay, so they are not able to learn continually. So that's basically limits their capabilities. And that's why human in the loop is very important in any agentic framework. So uh, second aspect is that their even their capabilities are very jagged in nature, and by jagged I mean on one hand they're able, in fact just last month they were able to solve ADOS problems in mathematics. So ADOS gave some conjectures and they were able to solve, LLMs were able to solve some of those conjectures, but at other times even simple things they fail to do if you ask those questions in a twisted way. This is very unlike human beings. Okay, so uh, for example, I can't expect from any IIT folks that he can't tell me what is 5 times 10. Okay. But if you pose this question to LLMs in a different way, many times they fail to answer this very basic questions, very basic question. So that again is a problem, is a big problem for LLMs, and that's why they're still not at a level where people try to project they have reached. Okay, so anyone who is grounded in research will tell you that AGI is a distant dream even now. Okay, and some of the reasons are because of these things. So another very important aspect is in terms of agentic AI. As I mentioned again and again, they are very good in planning, but they plan on a very short horizon. So, unlike human beings. So, to give you a very famous example that we keep hearing since last few months is Suryavanshi. Okay, his father wanted him to become a cricketer right when probably he was 3 years old, and he planned the journey out for next 10-15 years. So we can plan out our journeys for on a very long horizon. We can plan out things for multi decades. Okay, unlike agents, because their context is limited and because their learning is frozen in time, they plan only on short horizons. That again is a big problem. And recently, I will give you an example, an analogy which Demis Hassabis gave in one of the lectures that he gave here in Delhi during the AI summit. He said, let's train a LLM model with all the knowledge in the world till 1911. Okay, till 1911, let's take all the knowledge that was there in the human history and train a model. Will that LLM model be able to produce general theory of relativity, which was given by Einstein in 1915? So his hypothesis was that LLM will fail to produce anything close to general theory of relativity just by using knowledge till 1911, and that's a problem. So all these agentic AI frameworks are very good if we utilize these as tools which are supporting our endeavor rather than really something like a magic wand which can create any and everything that is required. So just keep that in mind. These bottlenecks that are there, in the end, they are next word prediction models. They do not learn continually. Their learning is frozen in time, and their responses, their learning capabilities are very jagged. They can do some very fabulous work, but then fail to do very simple things. uh, Unlike human beings, which, for example, we can learn maths, we can drive car, we can play football, we can do all kind of different things. uh, these agentic systems are not that capable yet. Okay, so let's talk about these final two slides, where I want to bring your focus on how things are working in enterprises. So this is one of the problems that is there in enterprises. So we have this product, and we have to make this product accessible. And by accessible, I mean people with disabilities should also be able to use our product. It's a requirement, it's a legal requirement in European Union and even in US. And in general, people love products who are accessible in nature. So we keep getting a lot of accessibility related bugs. So just last year we got close to 1,000 bugs which were accessibility related in our product, and we have to deploy really 4 engineers for an entire year to fix those bugs. This year we shifted to agentic AI frameworks, and within 6 weeks we were able to fix around 300 bugs just by using this agentic AI framework. So I just want to walk you through the architecture of that particular framework in these two slides. So first, as I said, there is an orchestrator which basically it has no knowledge of code base as such, but given some inputs, it can invoke relevant agent and it can plan out the things. Okay. So of course, we want to provide inputs to our agentic framework. These inputs primarily come from Jira tickets. So Jira is a basically a system where we log in bugs. It's a basically workflow management kind of a system. We have our GitHub repositories, and we create a RAG around it. Okay, these are our inputs. These are given to a agent which we are calling senior developer because we have defined its skills as those of a senior developer. It basically analyzes the images that are there on the Jira ticket, which are showing the problematic areas. It identifies the relevant portion of our code base where the fix is required. And it's a tough problem because Acrobat code base itself is millions of lines of code, more than 30 years, thousands and thousands of engineers have worked on it. So it's not an easy job. And on top of it, it is written in C++. So all these coding agents are still not that good in C++ kind of languages. They are very good in front end languages, but not so good in C++ kind of languages. Okay, so it basically uh, analyzes all these aspects and creates a shared memory. Okay, this shared memory along with the plan that is being created is shared with a junior developer agent. Okay, so uh, you can think of a junior developer agent as someone who is 1 to 2 years into job, and he has been given a task of fixing these bugs basically, but it is being done in an agentic manner. So he generates a fix, then we have deployed a tester agent. So all these are agentic frameworks, and again, this shared memory shared it tests the fix that is being generated by the junior developer agent, and it basically then sends it to a reviewer agent. And this cycle basically goes on. If the confidence score is below 90, it again gets back to the junior developer. It fixes it again, tries to fix it again. And this loop continues for 3 cycles. If the confidence score is above 90%, it gets merged to PR. Otherwise, we provide a comment that the confidence is not high, and this requires a human in the loop, a human developer who is going to fix the agent. Okay, and one thing that we notice, because uh, accessibility bugs have patterns and they are repeatable in nature. Just a simple already fixed in main pipeline, if this particular agent, what it does is it just checks every bug that is there on the Jira ticket and sees if it has already been fixed or not fixed. It just does this particular aspect. That itself saved us a lot of time in terms of uh, total time that it took. So from 20 minutes to 5 minutes, we were able to save 75% time just by introducing this already fixed in main pipeline kind of a agent. Otherwise, a human would have taken at least a day to just figure it out whether it has been fixed or not. Okay, so that's it from my side. I hope it was useful, and I am open to questions.
Thank you so much, sir. That was super insightful. I mean, personally, I learned a lot from that session. So let's now move to the
Thank you.
questions. All right, we'll first start with the questions sent in the chat. Then we'll move on to the questions that were posed in the Google form we sent before the meeting. In the meanwhile, if any of you has any more questions, we'd like you to send them in the chat so that we'll come back to the chat questions later on. So as of now, we only have one question in the chat, which is what is the difference between generative and agentic AI?
So basically, generative AI, as so there are two things that a model can do. Either it can do a classification kind of thing like dog and cat and all that, or it can classify things into multiple classes, whether something is a spam or a non-spam. Generative models are basically those models which are generating something. They are generating images, or they are generating some kind of a text, or some kind of a let's say rephrase. If you want to rephrase something, these are all generative models. So that distinction is more on the model side of things. So there are generative models, and then there are classification models. Okay, so what are known as discriminative models. So discriminative models and generative models. Discriminative models discriminate between different classes. Generative models give you something as a output which is generated from the model. Okay, which is like an image or a text. Agentic AI is more of a framework where you utilize generative models along with tools, along with memory and context to build real world applications. So that's the difference. So agentic AI is more of a framework, generative AI is more of a model.
Okay, moving
All
on to
right.
the next question. Uh, what kind of jobs can I get after BTech in the domain of AI and ML? I want a role in which I can take the leverage of both DSA and AI skills. Can you please mention some of such roles?
So as I mentioned, DSA are still very important. Okay, so uh, being engineers from a premier college like IIT, it's pertinent that you understand what is going on under the hood when you create these systems. Uh, AI ML is basically now all prevalent. So if you go in any industry today, especially in software domain, whether it is Google or Microsoft or Adobe or any other big company, or any startup, you have to have a very good understanding of AI frameworks. At least you should be able to understand the vocabulary of AI, even if you do not understand all the mathematical nitty-gritty that is going on within the model. I mean, the underlying linear algebra and probabilistic theory that undergoes in developing these models. Again, that is not very complicated. So I think the knowledge of DSA is very important in terms of building the systems, and that is a critical role that is really required in today's world. So because you understand data structures and algorithms, you can definitely devise better agentic systems, because it is not just about LLMs, it is about much more. So even a product which is very heavy AI oriented product, I would say AI constitutes just 20% of that product. Rest all is still good software engineering, which requires DSA. So, and another important aspect, which I think I will emphasize it again and again, is more than the technical know-how, it is also very important to understand how consumers are coming and interacting with your product. So data analytics becomes very important. Your UI becomes very important. Um, how customers are coming and interacting with your application becomes very important. And every single thing requires a good understanding of DSA along with AI. So I would say these two skills complement each other a lot, and you will be in a very, very good shape and in a very good position within an enterprise if you have mastery over both.
All right. The next question that we have is how exactly is using a multi-agent system more efficient than a single agent system? Also, how do we decide upon the agent interaction and getting the best outcome? Because the individually best outcome might not be the same as the overall best outcome.
Okay, so I think it's a very good question, to be fair. So having a single agent do all the things have problems, and they creep up the moment you start working for a product. So why these problems come in is important to understand. So these LLMs are very good in planning the things out. What they are not good at is the repercussions of, let's say, if a particular step in the plan fails. They are not good at it at all. So you need to understand they will plan it very well, but and they will start executing all the things if you have a single agent. uh, but the repercussions of failure is something which they fail to understand properly. So that is one reason you want to have, just like in programming paradigm, you want one function to do one job. It is very similar to that particular aspect. You want one agent to perform one single task, so that for one you can identify where exactly failure is happening. It will be much easier to understand that. Uh, so I think secondly, other aspect that we realized while working on this accessibility bot was it's important to mix and match different LLM models behind the scene. So what happens, and there are multiple papers in this particular research papers in this domain, that LLMs prefer their own outputs, and that's not good for a system. So you build one, for example, you create an agent which is a coding agent using Claude, but uh, put your reviewer agent on ChatGPT 5.5 or something like that. Okay, so mixing different LLMs behind the scene makes much more sense. You will gain tons of accuracy if you do this rather than utilizing a single agent which is using a single LLM. So I think these two aspects make having a multi-agent framework better. And there is evidence in almost every software development that is happening around the world for this. And what was the second question?
Uh, the second question was that how do we decide upon uh, getting the best outcome, because the individually best outcome might not be the same as the overall one.
Okay, so I mean, there is no theoretical framework for this, but what we learned is that during the initial stage, so for example, as I mentioned, there were 300 bugs that we wanted to fix. So initially, 40 to 50 bugs, human in the loop becomes very important. And that's where subject matter expert becomes very important. And that's where I'm telling you again and again that engineers cannot be replaced, because you need subject matter experts who look at the outputs, who basically see what is going wrong with these agents, and then they provide the feedback in this agents.md file, which basically is a prompts file. Uh, and then again redo the cycle. So when we were working on this, resolving the 300 bugs, in the first week, we were able to solve autonomously only around 5 or 6 bugs. In the second week, we were able to do around 50 odd bugs. Third week onwards, we were able to solve kind of 75, 80 bugs per week. And that happened because in the initial phase, human in the loop, subject matter experts, and their feedback became very, very critical. So that's how you improve the systems. And once they are into a stabilized phase, you can deploy these systems autonomously, and then they will start bringing in lot of productivity gains for the team.
Um, okay, let's move on to the next question. Which roles in AI and ML are the most demanding after BTech? Is it in classical ML or deep learning or agentic AI or something else?
So classical learning, if you know, it's always good, but that's not is currently the trend for sure. But sometimes I feel, and I have seen in my own journey here in Adobe, you can always solve problems using simple classical algorithms like TF-IDF rather than going to these large language models, which cost a lot, and they also introduce latency and other things. So understanding a good understanding of classical ML is always beneficial, but that's not something companies are looking out for at this stage. Yeah. Uh,
All right, let's move to the next question. This one's been posed in the chat. Um, what do you think of the tech market in the near future, like 5 to 6 years? Do we still need humans in the loop for sure, but the number of people required is going to go down?
so number of people required to achieve a particular task is definitely going down for sure. But as I mentioned, is it going to reduce the overall economic pie? That is not very clear at this stage. The past precedents, as I mentioned, when railroads came in, when electricity came in, these are all very disruptive technologies. If you think about it, uh, or when the World Wide Web came in, or the mobiles came in, these are all very disruptive. But did it really reduce the job market? I don't think so. In fact, increased the economic pie. It opened up new opportunities, and that's what I think is will happen with this AI boom as well. It will take some time for economy to realize all this. So people will be building new applications, new kind of interfaces, new kind of work profiles, workflows. Uh, so even though the existing tasks which are going on right now will be done in an agentic manner with reduced team size, but it will open up new economic opportunities. That's what I feel.
The next question is, how realistic is it to target a remote job role as a fresher after MTech? What should I do during the next 2 years to become a strong candidate?
So, I mean, first of all, I think it has become very easy. So one good thing about compute, so just to tell you my journey. So when I graduated from IIT, I had a software job as well as a core job with G Aerospace. I joined G Aerospace because I wanted to work in core domain. Then I worked for close to 10 years in nuclear industry. Okay, finally switching around 2016 towards voice AI and AI ML. And last 10 years, I have been doing this AI ML thing. So you need to understand few fundamentals. One is that you need to basically focus on what are the key things that are required for a good AI ML that are required from a good AI ML engineer. In terms of the foundational things I'm talking about, those foundational things are statistics, probability, linear algebra, and a bit of differential equations. That's it. So I was not a very good student in IIT, especially not in maths for sure, but I understood this particular aspect. And whatever I said, they are applicable in any engineering domain if you think about it. It could be a core semiconductor manufacturing or chip designing or aircraft manufacturing or anything. These are the core skills that you need. So if you really want to go deep and become a stud in basically AI/ML, you need to focus a bit on what is taught at undergrad level in linear algebra, how matrix operations happen, probability, statistics, and a very bit of differential equations for most of the enterprise roles, I would say. If you really want to go into core research areas in, let's say, Google or DeepMind, then it's a different ball game. You really need to have a lot more deeper sense of all these things. But in most enterprises, in terms of maths, this is sufficient. Now things have become very easy. You don't need to go and do any course which is paid in nature. You will get tons of open source resources, free resources, and you can learn from those. And with LLMs, things have become very easy. So enterprises are not, most of the enterprises are not focused on model building as such. They are playing on the application layer of it. So you need to, as I said, you need to understand how to architect a agentic AI framework, how to utilize LLMs in a cost-effective manner. So, for example, tokens are costly, right? So you need to basically devise algorithms which can really fetch the relevant code base with respect to the problem you are solving. So, as I said, Adobe Acrobat code base is millions of lines of code and you want to solve a bug, let's say in edit capability. So you need to fetch only that relevant portion from the code base. So these kind of things are very important. Model building, I would say it was important till 5 years back, but now not that important. But it's always good if you know how to build AI/ML models. That's always good. But again, there's a lot of resources that are available on the internet.
The next question we have is it possible that big tech firms automate most of their work with AI? And if it is possible, why hasn't it been done yet? For example, uh, they train different agents for different tasks, like through RLHF.
Yeah, so why they haven't been able to do everything is very clear. What I said, there are a lot of lacunas in these LLMs, in these agentic frameworks. So they are very good in doing a lot of stuff. So one is, of course, reliability. Another is security. And as you know, these are just next word predict token prediction models. They don't understand the physics around you, okay, like humans do. And as I said, they are not long-term planners. Uh, they are frozen in terms of learning. Continual learning is not there. So these are many of the things which make these the capabilities of the models limited. And researchers are working in the direction of making them more and more autonomous, and things are improving at a rapid pace as well. And they're able to do a lot of things which were not possible till, let's say, a few years back. But they are going to replace human beings in full is something at least I don't believe in. And yeah, RLHF and these things are really important. As I said, human in the loop is critical. So providing feedback to whatever has been created by subject matter experts improves these systems on a very rapid pace. As I said, from 6 bugs a week to 80 bugs in 3 weeks, we could reach just because we were able to give very good feedback to our agentic system.
The next question is, do you think future advancements will let local LLMs to get good enough to compare to modern day cloud-based models on decent consumer hardware? Realistically, how can
Yeah,
we
yeah.
extract the maximum performance with local models as chatbots or agents today?
Okay, so I think that's something which is very close to my heart, and I've spent almost last 2.5 years working on small language models which can be deployed on device. So there are few challenges. So you have to think about it in two different ways. One is a local model which is really local on the system, on the device, on your laptop, on your computer. Then there is another aspect or another framework in which you can think that the model is not very big. It's not like trillion parameters. It's like few billion parameters model, which can be deployed on a server, and you can basically expose that model to your application. And basically, you are serving your AI to your product free of cost, pretty much free of cost, except the hosting cost if you avoid. So on-device models have a lot of challenges, and the primary challenges comes with the multiple different hardwares on which it has to run. So especially if I talk about Acrobat, the Acrobat consumer base is very, very varied. So very, very varied. And we have consumers who are 50 years old, 60 years old, as well as young Janta as well, and their hardware varies a lot. So we have people still using Windows 8 and Windows 9 with no NPU or no GPU. So you have to do inferencing on CPUs. If NPU is available, you have to do inferencing on NPUs. And there are tons of variations in terms of hardware that is there on the system, number of cores, number of CPU cores that are available, RAM that is available. And this makes a small language model, which is purely on device, a very, very difficult proposition. But as I said, we are also shipping it. You need to convert these models in a format called Onyx, and you need to utilize some standard framework which is tailor made for your model, and then you can do it. The problem with very small language models like sub 1 billion parameter models is that they are not good at multiple NLP tasks, unlike, let's say, very large language models. So if you train or fine tune or distill these models for, let's say, overview generation, they will do overview very well, but they will not be able to do, for example, question answering. So that's a problem. The good thing is that all these hardware providers, iOS, Windows, including, I mean, if we include iOS, Windows, along with HP, Dell, and whatever hardware providers are there, they are now providing these models bundled with operating systems. So, for example, whoever is using Mac in your institute, you know that Apple is already giving a foundation model, which is like 3 billion parameter model, uh, quantized in 2-bit and 4-bit, which can do a lot of tasks like rephrasing, uh, converting your text into bullet points, doing some image related things as well. But it is still not very good in question answering. Windows is also coming up with OS bundle models very soon. They have already shipped a Windows ML framework in their latest builds. which basically is an inference engine for these ML models. So people are thinking about these small language models, which can be deployed on device, but the older hardware is a problem. Thankfully, it is changing at a very fast rate. So in 2026, all these OEMs, which are manufacturing laptops, are expecting 2 in 3 laptops to be AI enabled. And it means that they will either have GPUs or they will have NPUs. So that's a good change. And I think going forward, let's say 1 or 2 year down the line, these small language models which run on device will become very, very powerful. So definitely, and for small language models, training is still a skill set which is very much required. So if you are good at understanding the basics of training the model, that is definitely going to help.
All right, so we have the final two questions now. Um, just a second. The first one is, yeah, what all should I consider while doing an agentic AI project? What all do recruiters look for?
So yeah, Matlab, to be very frank, if you are solving some real problem using agentic, so there are two aspects. So real world problems produce a lot of challenge in terms of a good quality data that you require. Okay. Uh, Unfortunately, most of the college projects are basically utilizing data from Kaggle or Hugging Face or these kind of resources, and there is no fault of yours. So I would my I will say that if you are creating a agentic project, think more in terms of the architecture part of it. Okay, what tools it is using, how efficiently it is using, what is the kind of how many tokens it is utilizing while calling the LLMs. Those aspects become very important. If you can understand and put that across to recruiters, they will be very happy. So for example, how you are building your RAG pipeline. Okay, how you are basically I don't know whether you understand RAG or not, but it's basically given a query, you want to only extract relevant portion from your inputs and send it across to LLM so that your token costs are less. So how to do that? Whether cosine similarity is a good measure to extract the relevant information, or there are better algorithms which you can utilize. So recruiters will be very happy to get to know these things because these have an impact on the cost. And so basically think not purely in terms of technical aspects, but in terms of product. Okay. And product means, as I said, much more than just the AI part of it. How users are coming and utilizing your product, where they are clicking, what kind of analytics you are building within your product, uh, how you are utilizing that analytics in improving your product, in prompting your users for upsell or cross sell kind of opportunities. So these are actual business problems that you need to understand a little deeply, and not just pure technical aspects of building these models, especially in the enterprise setting. So if you're going into core research areas, it's a different matter.
And the final question that we have is, what's your perception on OpenAI's vision of creating an AGI? Do you think it's realistically achievable? Just wanted some discussion on it about your
Yeah.
perception.
So I mean, both OpenAI and Anthropic, both Sam Altman and Amodai, right now they are playing a game of IPO. Understand this point very clearly. The AGI is, if you talk to any deep researcher in this domain, where whether it is Jan Lee Kun or whether it is Demis Hassabis, everyone, or even Andrew Ang, they all say the same thing, that AGI is still quite far. Why Sam Altman and Amodai from Anthropic are playing this game of that my OpenAI has done this, now it can replace all office workers, now it can do anything that legal professionals are doing. It is a game of IPO. So, as you probably already know, they are valuing their companies upward of $1 trillion. uh, so they want to build this buzz, is what most folks tell me, even in the Bay Area. So most of my friends, I don't know whether you know or not, but during our time, 80% of the folks used to go to US for MS and PhD, and most of my friends are there in US. So that's the sense we are getting. So I think it's more of a hype to create a buzz in the market, that AGI is going to come in next 2 years. Any realistic, any grounded researcher will tell you that this is not realistic and it is going to take much more time to even remotely reach that stage. As I said, the example which Dennis Hassabis gave, if we give all the knowledge till 1911, will a LLM today produce the kind of results which Einstein produced in 1915 on general theory of relativity? The clear answer is no. So even Dennis Hassabis, if you know about him, he won a Nobel Prize in chemistry and he is a computer scientist. He worked on protein folding structures, but he never claimed that he understands protein very deeply. Or what he did was to do a pattern matching so that we understood protein structure of protein for hundreds and thousands of different proteins. Earlier it used to take tens of years to understand protein structure, and that's why he got this Nobel Prize. And even in his own view, because of the problems that we discussed of continual learning, frozen in time state, as well as very jagged sense of achieving a goal, uh, and not being able to understand the physical world around you, I don't think it is achievable in next 5 or 10 years. At least that's what my feeling is. And this all this news media thing, which is being driven by all these companies, Claude, Anthropic, and OpenAI, this is more to create a perception because they want to they want to basically increase the value of their company. That's it.
Well, on that note, we'd like to end this meeting.
Okay,
Once
just
again,
just one thing. Yeah, just one thing I want to tell all of you. Just two. I will take 2 more minutes. So. Uh, I keep getting interns from all the IITs, even the freshers from all the IITs. One thing I want to tell you guys, since we met only last year, all our batchmates were there 25 years down the road. So, what I will say is just take it easy, learn, but don't fret too much about what job you are getting just after passing out from IIT or what others are getting. Everyone is going to do very well. So, one thing of late I have realized while interacting with interns and freshers in my company is that there is a lot of stress within the system, and not just in IT Bombay, even in IT Delhi, IT Kharagpur, Kanpur, everywhere, in terms of what internships you will get, what jobs you will get. So just relax a little bit. Everyone will do very well in life. So, and I can tell you because I met my friends 25 years down the line just in last December. Everyone is doing very well. So just relax. Initial job just after IIT uh, will take you only as much. Okay, so even if you don't land up in a job of your own interest, you can always keep working on your skills. One good thing with all of you is that, in fact, at IIT, we are being forced to focus more on fundamentals. So just keep that mindset on even after graduating from IIT, and things will be good 5 years, 10 years down the line for every single one of you. I can tell you that. So don't fret, don't take too much stress. So I heard that even internships have become very stressful in IITs, and that's something I really didn't like when these interns and freshers tell me these stories, because it used to be much more chill in my time. And I understand the batch size was also very small. We were only around 450 odd fellows in entire batch compared to 1200 odd folks in your batch. But still, in the long run, you all have achieved a lot. You all have done very well. You are among the best in the country. So if you folks won't do well, be sure India is not going to do well. So at least have that much confidence and live a fruitful, peaceful, wonderful life going ahead. Thank you.
Thank you so much, sir, for taking time out of your busy schedule and sharing your insights with us.
Yeah, thank you. My pleasure.
We truly
Yeah, thanks a lot,
appreciate your
Srishti.
guidance and are
Yeah, yeah.
grateful for the opportunity to learn from your experience. It was a really inspiring session, and personally, I learned a lot. We hope everyone gathered some helpful insights from the session today. The recording will be available soon. So thank you everyone for joining, and good night.
Yeah, thanks a lot. All the best. Thank you. Bye bye.